At the company's R&D Institute in Haifa, the research team, headed by Dr. Ruth Fried, conducted a series of comparative solubility experiments between standard and granular polysulfate and each of the nutrients it contains.
In all fertilizers, we tested the release of each nutrient in the same concentration of 0.25% weight per weight polysulfate during 24 hours.
In this series of experiments, solutions containing 1.25 grams of polysulfate to 500 milliliters of water were prepared and stirred during 24 hours at 25 degrees Celsius. First, we tested the solubility of polysulfate compared to other sulfate salts at the same nutrient concentration of 1,400 parts per million. We checked the release of sulfate salts during a 24-hour period. The fertilizers we used in this analysis were standard polysulfate, granular polysulfate, calcium sulfate, and potassium sulfate. From the results shown on the graph, 3 fertilizers, standard polysulfate, granular polysulfate, and calcium sulfate, reached their potential more gradually than potassium sulfate. In the next experiment, we tested polysulfate solubility compared to other potassium salts at the same nutrient concentration of 350 parts per million. We checked the release of potassium during a 24-hour period. The fertilizers we used in this analysis were standard polysulfate, granular polysulfate, potassium sulfate containing magnesium salt, potassium chloride, potassium magnesium sulfate, and potassium sulfate. The results: potassium chloride, potassium sulfate, and potassium sulfate containing magnesium salt reached their solubility very quickly, whereas granular polysulfate and potassium magnesium sulfate reached their solubility potential more gradually than the other fertilizers. Standard polysulfate sits in between the two groups. In the third experiment, we compared polysulfate solubility to other magnesium salts at the same nutrient concentration of 150 parts per million. We checked the release of magnesium during a 24-hour period. The fertilizers used in this analysis were standard polysulfate, granular polysulfate, potassium sulfate containing magnesium salt, potassium magnesium sulfate, and kieserite. Granular polysulfate, potassium magnesium sulfate, and kieserite reached their potential more gradually than magnesium sulfate and potassium sulfate containing magnesium salt. The standard polysulfate once again sits in between the two groups. In the final experiment, polysulfate solubility is compared to other salts, related this time to calcium, at a maximum concentration of 420 ppm. We checked the release of calcium during a 24-hour period. The fertilizers used in this analysis were standard polysulfate, granular polysulfate, and calcium sulfate. All 3 fertilizers show similar rates of reaching their solubility potential.
Unlike the other fertilizer that we tested, polysulfate is a multi-nutrient, and we got a good solubility rate results for each of the nutrients of the polysulfate. From our point of view, these are very good results.
In another experiment done in France, 1.25 grams of fertilizer was added to 500 milliliters of water at 25 degrees Celsius with no stirring during 60 days. First, measuring the release of 3 nutrients. Potassium and magnesium are immediately available. 99% was released after 5 days contact in water without stirring. Sulfur release is slower, limited by the maximum solubility of calcium sulfate. However, after 15 days, almost 90% is released. In a similar experiment, the relative release of sulfur was measured. Half of the sulfate associated with potassium and magnesium is immediately available. The other half, associated with calcium, dissolves more slowly. 90% is released after 25 days in contact with water without stirring. This means that polysulfate gradually releases sulfur, thus being less prone to leaching.